Hello everyone, this is your junior high school math teacher, and in this video I'm going to discuss the fifth week lesson in your Mathematics 9, and this is ratio and proportion. After watching the video, you should be able to state the fundamental theorems involving ratio and proportion, and you should be able to apply the fundamental theorems of proportionality to solve problems involving proportions. In this material, you would be able to apply the fundamental theorems of proportionality. Definition of ratio and proportion. In geometry, objects or figures having exactly the same shape but not of the same size are called similar figures. The study of similar objects and figures make use primarily of the concepts on ratio and proportion. A ratio is defined as a relation between two quantities of the same unit expressed as a fraction. The following are examples of ratio. We have 2 boys is to 3 girls. 2.54 centimeters is to 1 inch. And generally, A is to B. In each examples, two quantities have the same units. That is students, measurement units, etc. Or just to name a few. Now, what about the proportion? It is defined as, a proportion, it is defined as a mathematical statement expressing equality between two ratios. The following is an example of a proportion. A is to B as C is to D. Or, considering this equation, we read this the same way. A is to B as C is to D, where A and B are called extremes and B and C are called the means. In a true proportion, the product of the extremes equals the product of the means. That is, A over B is equal to C over D. Or, we can also write the proportion in this form. A colon B equals C colon D. But that is not how we read the equation. It should be A is to B as C is to D, where B and D are not equal to zeros or zero. Then AD is equal to BC if we do the cross product method. Okay, this will be the equation. Okay. The left side is the product of the extremes, while the right side is the product of the means. Now, why is it that B and C are called the means? Because these are terms closer to the equal sign. While AD, the reason why they are called extremes because they are found on the left and rightmost of this proportion. Okay. Now, what about the properties of proportion? Now, for A is to B as C is to D, we let A equals 2, B equals 3, C equals 4, and D equals 6. Now, we assume the values to these four terms in order to validate the following properties. So, now if we have A over B equals C over D, by multiplication property of equality, meaning we multiply both sides of the equation by the same quantity, which is particular B particularly BD. Okay? So what will happen to the proportion or the equation? Equation number 1 becomes AB equals BC. Okay? Next. Now, if we try to validate this transformed equation by substituting the given values for these 4 terms, so that is 2 times 6 equals 3 times 4. Okay? Meaning this equation is validated. Okay? It's true. Next. Again, we start with the same proportion, A over B equals C over D. Applying what? Again, multiplication property of equality, meaning we multiply both sides of equation in number 2 by the same quantity, this time by B over C. So what will happen to the proportion? The, the proportion becomes A over C equals B over D. Okay? Next. Of course, if we want to validate the new equation, so 2 over 4 is indeed equal to 3 over 6. Next. How about A over C again? Or this time A over C is equal to B over D. So meaning we start with this equation taken from number 2. And we apply the addition property of equality. Meaning both sides of this equation are to be added by the same quantity, and that is 1. So the resulting equation will become what? Quantity A over A plus C all over C will be equal to B plus D all over D. So validating the new equation, the result is still the same. Okay? 6 over 4 is equal to 9 over 6. So if we simplify both sides, it will result to the same fraction, which is 3/2. Next, fourth one, A over C is equal to B over D. Again, applying the addition property of equality, meaning we add or simply subtract both sides by -1, or the reason why it is still addition property of equality, it's simply because we are actually adding both sides of the equation by -1. Okay? So you just think of addition in this particular process. The reason why the application is still the APE, or the addition property of equality. So from number 4, the equation becomes what? Quantity A over C all over C is equal to quantity B over D all over D. Validating the equation, it will give us -2/4, which is equal to -3/6, which means that these two are equivalent. So the equation is also validated. Now, let us take some examples. Solve for the unknown B in the proportion 18 is to B as 27 is to 9. So we apply the principles of proportionality, or the fundamentals of proportionality, which means the product of the extremes is equal to the product of the means. So we take the product of 18 and 9, and we take that on the left side and equate it to the product of the means, that is 27 and B. Then dividing both sides by 27, so our B is equal to 6. Okay, next. Number 2, find the fourth proportion to 6, 8, and 18. So for our solution, now for the unknown fourth term, let us denote that as X. And we set up the proportionality, so that is 6 over 8 equals 18 over X. And we do the cross product method. 6x is equal to 18 times 8. and we divide both sides by 6, or better yet, we take the product of these two, that is 144, and from this resulting equation we divide both sides by 6 in order to find the value of x. So x is equal to 24. Next, number 3, find the lengths of two segments whose sum is 56 centimeters and whose ratio is 3:5. Solution. Let x be the length of one of the segments, and 56 minus x be the length of the other segment, since the sum of their lengths is 56. Next, then to set up the proportionality or the equation, so that is x over quantity 56 minus x is equal to 3/5. Ayan. Then we do some cross product method. So at this point, the equation becomes 5x is equal to 3 times the quantity 56 minus x. So at this point, we've just formed a linear equation in one unknown x. So on the right side, we apply the distributive law. And then negative 3x transposed to the left, so that the equation becomes 5x plus 3x is equal to 168. The left side becomes 8x, which is equal to 168. So divide both sides by 8. So that the value of x is equal to 21. Now this is just the length of one of those two sides. What about the length of the other segment? The other segment. So we take 56 minus x, which is equal to 35. So we know that x is 21. So that is actually 56 minus 21 is equal to 35 centimeters. So these are the lengths of the two segments. Next, the measure of two complementary angles has a ratio of 2:3. Find the measure of each angle. For our solution, let x be the measure of one angle, and 90 minus x be the measure of the complementary angle to x. Then we set up the proportionality. X is to quantity 90 minus x is equal to 2:3. Then solving for the value of x in this equation, we do the cross product method, so that the equation becomes 3x is equal to 2 times the quantity 90 minus x. Then simplify the right side. So the right side becomes 180 minus 2x. Then negative 2x transposed to the left. So the equation becomes 3x plus 2x is equal to 180. And we have 5x equals 180. So divide both sides by 5 to get the value of x. And that is equal to 36, or 36 degrees, which is the measure of one angle. Now, to get its complement, we take the expression 90 minus x. And we know x is 36. So 90 minus 36 is 54. So the two angles are 36 and 54. So they have the ratio of 2:3. Okay. So by checking, 36 degrees is to 54 degrees. When you simplify it, the ratio, it will give us 2:3. So we drop their common factor, which is 18. Next, number 5, geometric mean. It is defined as the mean between two numbers in geometric sequence. The geometric mean of two numbers is the square root of the product of the two numbers. So with that, let us take some examples under number 5. Find the geometric mean of the following pairs of numbers. Okay, let us go first to letter A. Okay. So to get the geometric mean, we take the square root of the product of 18 and 8, and that will give us 12. For letter B, the geometric mean between the two given fractions, we do the same thing. We take the square root of the product of 8 over 9 and 18 over 25. And the answer is 4/5. For letter C, we take the square root of the product of these two radicals, simplifying the resulting radical in letter C. The geometric mean is 12. And for letter D, we get the square root of the product of 16a cubed and 9a to the 5th. And that is 12a to the 4th. And finally, for letter E, the geometric mean of these two given terms, so at this point, it's the square root of the quantity 81 x to the 12 over 36. That is actually 3x to the 6th all over 2. Next, we go to number 6. Solve for x from the following properties. So under number 6, we have two items. First, we have letter A. 24 over x is equal to 18 over 6 square root of 3. So what do we do? Okay. So we do the cross product method. You multiply 24 by 6 square root of 3. And this is the result. We take the product on the right side, and on the left side, that is the product of 18 and x. Okay. So again, we use the cross multiplication or the cross product method. Then, simplifying the right side, it will give us 144 square root of 3. Then divide both sides by 18. And that will give us the value of x, which is 8 square root of 3. Now for letter B, we do the same thing. We use the cross product method. So that is 35x is equal to the product of these two. 7 square root of 5 times 3 square root of 5. So the left side is what? 21. Then square root of 5 times square root of 5 is 5. Of course, 21 times 5 is 105. Then divide both sides by 35. So x is equal to 3. And that would be all for now. And we'll see you next time for the next topic in Mathematics 9.